Hi, Tony from It Talking Remote, back again, second cast for the day, believe it or not. And this is a fantastic one. I've got the wonderful Dave Farley, who got up early in England for me just to do this cast. How are you, Dave?
I'm very well, thanks. How are you?
Oh, great. And I appreciate you getting up so early because Dave's an evening person, but he's done this specially for me. So I'm really appreciative. If you're watching, don't forget remoteaf.co, join our community. Lots of people talking about it, lots of like-minded things that you'll hear today. And of course, sign up for our Team Craft newsletter. You can find all the details in the notes, and everything that we talk about today we'll have in the show notes as well. Without further ado, Dave, lovely to have you. But for those that don't know you, could I ask you to introduce yourself?
Of course. So I'm Dave Farley. These days I'm an independent consultant. My background is as a software developer, largely at the more complicated end of things, usually bigger systems, large distributed systems, high performance trading systems was where I kind of finished up in my building stuff career. These days I'm probably best known as an author and a YouTuber, rather strangely. So I'm one of the authors of the Continuous Delivery book and a book called Modern Software Engineering, which talks about what it would take for us to establish an engineering discipline for software, what that would mean and what it would look like. And my YouTube channel is called Continuous Delivery, and we release content daily that gives people advice on how to do a better job of software development.
So you're continuously delivering on your YouTube?
Yes, we're continuously delivering on the YouTube channel.
Brilliant. The irony wasn't lost on me then. I just went ahead. So the reason I got you on today, obviously, is that Modern Software Engineering, the book, it came out in the COVID piece, and I had the opportunity to read it. I thought it'd be great to have you on because, you know, the things that are in are fantastic. For those that are watching this, we're about to geek out on some software-ish stuff, so just beware. But I'd like to start talking about it a little bit. There's some things that you pulled out, and I've unashamedly written some notes, so I will read off a couple of these as we go. But some of the things that I saw in the book that I really like was, we'll start with the tools sort of thing. And you know, you're really clear about choosing the tools based on sensible criteria. And for anyone like myself or those who've worked in organizations where they use the square peg, large mallet, and a jack to try and do the work, that really rings home. Talk to me a little bit about your thoughts on that, Dave.
So I think in general, if we are to start taking a more engineering approach, that ought to have some implications for the sorts of things that we do. And one of the things that we want to be able to do is that we want to be able to take, to my mind, a more evolutionary approach to incrementally building systems, which means making progress in smaller steps. And to be able to do that, we want quick feedback on whether those steps are successful or not. And to be able to do that without getting confused all of the time, we need to control the variables. So first step with choosing any tool from my point of view is, can I version control it? And if I can't version control it, I'm not interested. Doesn't matter what it does, doesn't matter how wonderful it is. If I can't version control my use of that tool, it's not really a useful tool. And then I want to be able to get that in under version control. I want to be able to get that into a position where I can use it and use it reliably. So can I automate the deployment of that thing? Those are criteria that I would certainly use to as part of the selection process for those tools. If I can version control it and I can automate the deployment of it, then that means I'm able to control the variables sufficiently to then make sensible use of it, reproducible use of it. And so only if I was forced into a corner of there was no other way of doing it, if I got a choice between one that was version control and one that wasn't, you know, I'd always choose the thing that was version controllable. Then the things that I'm looking for are really how fast does it give me a result, because it's my belief in terms of this way of working is that we want to make progress in these small incremental steps. And that means to be able to facilitate that, we need to optimize for very fast, very clear feedback on the correctness or otherwise of each of those small steps. We want to fail fast in the kind of classic agile approach. It's a very different experience for me to find out that I screwed up and introduced a bug that's destined for production within minutes compared to finding out in the following week. They're very, very different experiences. So we want to find those mistakes earlier in the process. And so we want tools that are fast like that too. So for example, classic example, I quite like static analysis tools. I like tools that give me deeper insight into the nature of my code. But if it takes me hours to run the static analysis pass on my code base, that's not very useful. So I'd prefer lighter weight analysis that I can run in minutes or seconds rather than deep heavyweight insights into the code base that takes hours.
Yeah, I can see that because the worst thing that we see with these tools is that they use them to build something, and then you sort of say, well, okay, how do we tell? How do we tell that we've been successful, or how do we tell?
Yeah,
and it's sort of like a basic 101, but you see it so often, don't you?
Yes, and often we treat the tools as though they are defining the way that they work. They're supposed to be tools. We're supposed to be deciding how we want to work, and then we find tools that fit in with our way of working. My way of working is to work in small steps and get great feedback. So I want the tools to fit in with that, and that's part of the criteria that I'm going to use to judge them.
Yeah, and I think that's the piece you've got in the book there. That's quite you're quite strong about organising your work systems that allow you to facilitate and continue that incremental progress.
Yes, absolutely. It's one of the kind of themes of the book, the kind of pillars that the book's built on, is that I think that an engineering approach is built on two core concepts. One of them is optimizing for learning. I think that software development is a process of exploration and discovery, and that as software developers, it is our job to become world-class experts at exploration and discovery in the context of building software. And the other part of it is software systems are hugely complicated. And so the other pillar that we kind of build this discipline on is managing that complexity in ways. So using techniques like modularity, cohesion, separation of concerns to maintain our software in an easy to change state. And that's how we manage the complexity. So we use feedback and incremental learning and experimentation to allow us to learn things. And we facilitate that through design choices, technology choices, automation and tooling to give us the feedback that we need to allow us to achieve those ends.
Yeah, and I think that's the piece where you really focus in on, let's build thriving systems.
Yeah, and
not just legacy code. Like we've all seen where this code's been built, and we know that code's not going to be useful in 2-3 years' time.
Yeah. Before we started the stream, you and I we were talking about agile and agility, and I think this is one of the key ideas. I think that one of the deep philosophical differences between an agile mindset and what went before is that what agility is really about is the freedom to make mistakes.
Yeah,
and that's a remarkable freedom, because without that freedom, it means that we've got to get everything right first time, and the chances of us succeeding at that are minuscule, tiny. And so what agility allows us to do is to start off, make mistakes, and recover from the mistakes. That's really what it means to my mind. And so any engineering discipline worth its salt must do the same thing. So when I talk about engineering, I'm not talking about some kind of rigid, predetermined outcome. What I'm talking about is using engineering as an approach to narrowing the field of solutions to the ones that aren't stupid. So we're going to exclude the ones that are dumb and aren't going to work, but we've still got an infinite range of choice of solutions that will work within those, but we rule out the bad ideas, and I think that's what engineering in general does. Realistically, if you look at it deeply, I think that's what engineering is for.
And I think, as you said, we were talking before the stream, when we were talking about that, you were saying about those ideas, we need them to act as guide rails, so that we understand the stuff that works, right? The ideas
Yeah.
and tools.
Yes, and I think in other engineering disciplines, that's what we say. That's what we see. So one of the core ideas that I think is common to engineering and we often miss is iteration. So iteration in other engineering disciplines might work at a slower scale, but it's there. So I'm one of my side interests is I'm interested in aviation and the history of aviation. If you look at the history of aviation, it's one of continuous iterative progress over a century. I mean, it's not fast, but nevertheless, and we've learned from every time there's an accident, we study the accident and analyze it to see if there's any lessons that we can learn from that to stop us having the same kind of accident in the future. And the result of that in engineering across the board, really, but a good example from aviation is in the early days of aviation, nearly all of the aviation pioneers were killed by the machines that they were innovating in. And in 2017, the equivalent of 2/3 of the population of the planet flew in commercial airliners, and no one was killed.
Wow.
That's what that kind of iterative approach to solving problems can achieve. In software, we've got lots of advantages because we can iterate more quickly than that and learn more quickly than that. But I think it's the same idea.
Yeah, and I think that goes hand in hand with the other thing that we were talking about, which came from the book as well, which really resonated with me, was that learning from history and experience, right? And in software development, over the years, we've been pretty bad at that because we keep reinventing the same thing or revisiting the sins of the past, if you like.
Yeah, it is. As we were discussing, we are two gentlemen of a roughly similar age, and one of the downsides of that is that you tend to look back and say, "Oh yeah, in my day," and all that kind of thing. But there aren't that many new problems, and an awful lot of the problems that we face in software are depressingly the same problems that we were facing in the 1980s or even 1970s. One of the most beautiful books that I remember reading about software development was The Mythical Man Month by Fred Brooks, published in 1970. If you read that today, the stuff that he's talking about is still as true today as it was in 1970, even though the computers that he was talking about were using punched cards and paper tape. The problems of organizing ourselves as human beings to be able to create this weird, ephemeral, fragile stuff we call software are the same. And so we should be better at learning from history, and we are not great at that, which is a shame. And in part, that goes back to what we were talking about, when you were talking about tool choice. How do we rule out the bad ideas? How do we determine the difference between a good idea and a bad idea? Because not all ideas are equally valid. The earth isn't flat, and waterfall doesn't work for software development. So, there are some ideas that are just mistaken. And how do we identify those and stop doing those? And in software, we're not actually terribly good at even ruling out the bad ideas. There are still lots of teams that I see that are essentially, whatever they call it, practicing a form of waterfall development where they need to do all of the work at the start to get it right in their world. I don't believe that works because of this profound nature of software, which is about discovering the problem as we go and learning how to fix it as we go.
And I think that goes hand in hand with the other thing that we're talking about. With all of that, we need to achieve rigor.
Yes.
Without it being too rigid, because that goes hand in hand with the agile process and the iterative nature that you're talking about. But we see a lot of this rigidity enforced. In fact, unfortunately, what we still see is that it's enforced by a hierarchy often.
Yes, very, very much so. And I think that's part of it's the kind of the sociology of it, the social dance, the organizational cultures in which we inhabit. Naturally, and software is weird, and people have weird ideas about what it is and how it works, and there are assumptions that we can treat it like some kind of production, process, trying to build a production line of some kind, and that it's a production problem. And I think it's probably $1 trillion mistake that we've spent decades of trying to solve this as though it's a production problem, and it ain't, because our production is free. So we can, whatever the nature of the software systems that we build, the output of software development is a stream of bytes. And when you pause and think about it, one of the remarkable characteristics of a stream of bytes, however big and long, is that we can clone it for essentially zero cost. So production for us is just copying the stream of bytes. The difficult part of software development is the design and discovery of the problem. So part of our job as software developers is to learn enough about the problem to understand it well enough to come up with designs that will solve that problem, whatever it is. That's the hard part, and that's the part that is about exploration and discovery, not about place peg A into slot B or whatever else. And we try and turn it into that kind of automatic progress as though it's a production line, and it's not a production line. That's understandable to some degree for non-technical people that don't understand how software works. But I think that what we technologists have tended to do is to abdicate quite a lot of the responsibility for our expertise. There's a lot of stuff. If you're going to employ me to build some software, forgive me sounding big-headed, but I'm an expert in software development, and I mean that for all of us. If compared to somebody that doesn't write code, if we are the experts in software development, so we are going to have ideas and input into the approach and the process that is at least equally valid to any business input or whatever else. And the classic failure mode of this is kind of the feature factories that we see all of the time. These command and control organizations who are optimizing to build feature. And what the data says, the DORA metrics say, is that there's no trade-off between speed and quality. The way that you go fast is that you build high quality systems, and high quality systems is our part of the game. That's the stuff that we are going to understand. High quality, by my definition in software engineering terms, a high quality system is easy to change, and we work using modularity, cohesion, separation of concerns, abstraction, loose coupling, those sorts of techniques. We work to maintain our systems in an easy to change mode. We use techniques like continuous delivery, feedback on our systems, so we can change things easily. And that, for me, is close to the whole game. If it's easy to change our systems are high quality. And if they're not high quality in some other dimension, like security or scalability, we can make them high quality because we can change them. And if we can't do that, then what we end up is going slower and slower and slower and slower over a time. And we see that all of the time. So it's a profound mistake, even on the terms of the business who just want to build lots of features. You want to build more features, then build high quality features. That's the way to go fast.
Yeah, it's the old adage, isn't it? You employ smart people. Why would you hobble them, right?
Yeah.
And it's interesting. That goes to something else that you and I were chatting about previously as well, which sort of clicks into that, which is, software is a thing where we actually really have learned what really works.
Yes.
But there are organisations that actually do that well, and there's such a chasm between the organisations that don't do it well, and we were chatting around that.
Yes, I think that's true. I think I'm associated with this, so there's a degree of hubris again of me claiming this, but I think it's fairly widely recognised that continuous delivery is pretty close to state of the art for software development. And if you look at organizations that all of us would think of as being good, excellent at software development, they all practice to some degree some form of continuous delivery pretty much. The only exception that I can think of is Apple. and and I'm not entirely sure that that's because Apple don't do it. It's just that they don't talk very much about what it's like inside. But I can point to organizations like Google, Amazon, Netflix, the common ones, Spotify, those sorts of big web companies, but also Tesla. Tesla's factory is a software process. Tesla is a continuous delivery company. Tesla make changes using continuous integration and deployment pipelines, and they can do remarkable things. There's a lovely story from Joe Justice about Tesla deciding one day that they wanted to upgrade the maximum charge rate in a Model 3 car from 200 kilowatts to 250. The factory is essentially a big robot. So despite this being a physical change in the design of the charging circuits for the car, changing the size of the copper cables that were in there, amongst other things, it was largely under software control. So somebody made the software change. They committed the change to the deployment pipeline. The deployment pipeline whirred through. 3 hours later, the production line in the factory was producing cars with a maximum charge rate of 250 kilowatts. That's the kind of thing that's possible when we start treating this engineering discipline seriously. And you can look at Amazon releasing 1.5 changes per second in production, and Google with 9.5 billion lines of code in a single repository and doing trunk-based development. These things that seem almost impossible are not. They are possible, and we can do those things. But there seems like a big gulf between those sorts of organizations and what we think of as average in software development. But the gulf is not really about the size of the organization, the complexity of their processes. It's largely about the mindset, about the way in which we think about and organize ourselves to conduct software development, to my mind.
Yeah, it's interesting. I'll just say, I'd read Joe Justice's, but when we were chatting, the one that you blew my mind with was the Tesla example of pushing to the rocket before it's just about to launch.
SpaceX, yeah.
SpaceX.
Yeah, yes.
Wow.
So SpaceX are also a continuous delivery company, and one of the things that's fascinating about them is they're applying the kind of what we think of as the software ideas and approaches of modern software engineering to space rockets. They're building space rockets in small iterative steps and building prototypes and trying them out and throwing them away really fast. One of the things that SpaceX do, so they also have deployment pipelines for their software. They're doing test-driven development, trunk-based development to space rocket systems, the flight control systems on their space rockets, and SpaceX are doing all of those techniques, and they are pushing changes to a space rocket up to 40 minutes before a launch. This is a launch that's carrying human beings up to the International Space Station, and that's safer because they're working in small controlled steps, and that's part of the game. So the idea is that we can de-risk software development, not by being slower and more thorough in that sense, but by being faster and more thorough. If each change is tiny, the amount of risk associated with each change is tiny as well. And we can evaluate that more clearly and understand the implications of each small change more accurately. And so there are several organizations that I'm aware of that are working on safety critical systems this way.
Well, and as you said before, I was giving an example. I walked into one particular company, and it's just a culture of, like, they don't even see it as something different. They just see it as that's just how we do it because that's the right way to do it. Whereas the companies that are where that gap, they challenge it or that the investment in that time of that kind of stuff seems to be challenged, and I'm not sure why that is.
Yeah, it's one of those things. We talk about all of these benefits, and one of the difficulties is that the difference between working this way and working in more traditional ways is so profound. it does challenge a lot of the ideas that we're kind of comfortable with and used to organizationally. The idea that you can build a safety critical system by going faster rather than slower sounds counterintuitive. It sounds wrong. It doesn't sound like the right thing to do. But there's quite a lot of data and evidence that seems to back that up. And there are organizations that are practicing this. And the change failure rate that you get if you work in these smaller, more controlled steps is dramatically lower than if you're building, you're releasing change into production in large batches. And so the difficulty with continuous delivery is nearly everybody that I know that's experienced it personally would never willingly go back to work in the old way afterwards. But it's a challenging thing to do because it does challenge a lot of preconceptions and assumptions. And that's doubly difficult in large organizations with a history and a legacy of software and culture around software development. It's a difficult change to make. I make a living of helping organizations to try and make that transition, but it's incredibly difficult to make that transition. And I'd be a very wealthy person if I could put continuous delivery in a bottle and sell it, if it was that easy. Yeah. But it's not that easy.
I've got a bit of a theory on it though, so it's a bit of an indictment on well, it's not just agile, but it's organizational construct. Because some of the things that I see, like I can tell you about an organization that I was in, and I was there to do a bit of an assessment, and one of their teams had taken on this process. They had CI/CD. They could actually launch every hour on the hour if they wanted to, right?
Yeah.
But they weren't allowed to.
Mm-hmm.
Because they had to go through the change advisory board, and then it had to have 73 different ticks, and then it had to go through that, and they had to see all of the test results, and et cetera. And I think that's one of the big prohibitors. It's not actually the actual capability, it's the process around it. And I think that's where Agile gets it wrong sometimes, because they're so focused on that process orientation rather than how you do it.
Yeah. I characterize continuous delivery as an approach as really grounded in two things. One is kind of scientific rationalism. It's this engineering approach. We're trying to do stuff based on evidence and facts as far as we can. And the other one is kind of lean, the kind of lean manufacturing. We're trying to do that with the least amount of work. So how do you take work out, of the process? And in the example that you just gave, you everything's got to justify its value. So if I am building a deployment pipeline and I am going to reject any change that fails a single test, why do I need a human being to look at the tests? Well, if a team is comfortable that the tests are sufficient to determine releasability, why do I need any other sign-off other than that? If I've got to do regulatory compliance, which is a large part of the kind of organisation that I worked in the latter part of my career, then the data from the state of DevOps reports says that things like change approval boards are negatively correlated with quality.
Yeah.
The slower you go, the worse the quality of the systems. So the best way of organizing things is to dump your change approval boards and do something else instead. So I'd go down that route, and I have done that route. So I'd build compliance, for example, into my deployment pipelines so that the deployment pipelines assert whether the change is compliant or not, and reject it if it's not. And this is a change in mindset, and part of the difficulty of adopting this is that you've got to kind of overcome the institutional scar tissue that's built up around some of these kinds of behaviors over the years, and that takes a long time. When I'm talking to clients, when I'm advising as a consultant, I generally say, depending on where you're starting from, if you're starting from kind of the average position, which I'd describe as kind of flaccid scrum, then if you're starting from there, it's probably going to take you 2 or 3 years before you get good at this. But it's not going to be 2 or 3 years before you're improving. you'll be improving within a matter of weeks. But it's still going to take you 2 or 3 years before you really get to be good at it, because that's how long it takes people to change their minds about something as fundamental about the way that their normal reactions to the way that they're working. So nearly, in a traditional organization, as soon as the pressure comes on or things start going wrong, it's so easy to fall back to old habits as, oh, well, we'll introduce more bureaucracy, we'll do more inspection, we'll do more sign-offs. Just doesn't work, though. That's not the way to do it. That's not how we build high-quality systems.
Yeah, and as I said, obviously I've been doing Agile a long time, and I know how it works when it works really well. But I think over the last few years, I've seen this bent of really miring it in process rather than the actual true things, particularly in the software environment, right? There's so many variables in software. Humans are the blip in the radar, how we design software, et cetera, that you have to have that ability to have agility rather than just the agile thing happening all the time.
Yes, yeah, and it's ultimately it's practical agility, being able to change your mind, react to a mistake, and correct the mistake. That is really the value here. It's that freedom to make mistakes that we talked about earlier. That's so important, and the process and all of the rest of the stuff are just advice or suggestions, techniques of ways in which you can achieve that. And if they're not that, then they don't matter.
So I'm going to take a little bit of a right hand, but it's related to this because we're chatting about it as well. And not that it's actually part of the book, but I think when I read this and I listen to what you're saying, and now with the advent of AI, and I see people using AI to write their code, and forthrightly they're doing it. What do you think about that, and where do you see that going, Dave?
So I'm a scientific rationalist, and so my assumption is that there's nothing. I'm not a spiritual person, so my assumption is that there's nothing special about the physics of our brains that means that you couldn't recreate that in some other substrate. So do I believe that artificial general intelligence is possible? Yeah, I do. And at that point, as soon as you assume that, why would we assume that that's limited to our level of capability? So I assume that one day machines will be smarter than us and we'll be able to do everything that we can do. I don't assume that there's a barrier to that. At that point, all bets are off across the board pretty much, but certainly in terms of software development, because they'll be better at it than us. At the moment, we're not there, and the tools that we have right now are interesting and helpful, but they're not. If you want your AI, if you're going to build your business around AI writing the software for you, good luck with that. It's probably not going to work very well. The software development is more complicated, more tricky than that. AI can help in some relatively marginal but interesting ways, I think. So I've played with some of the kind of Copilot style tools, and they're useful in allowing me to go a little bit faster at doing things. But the creative bits are still me. The bits that are necessary for me to be able to build software like that. So even at the level of prompting, if I want to be able to prompt an AI to generate some code, what am I really doing at that point? I'm coding. I'm just writing code in a different, a less formal programming language. I'm using English, in my case, to prompt the AI, and hopefully it's going to generate. My experience is, when I've tried to do that, is it's remarkably like coding, and the level of detail that I have to get into to get the results that I want is remarkably close to writing code. And actually, writing the code is more efficient for me, because if I know a programming language, than trying to do it in English, which is too vague and too imprecise. So there are some limitations there, but also some value. The other place that I see AI talked about a lot is using AI to test code, and that's a big mistake because I think that's after the fact testing, and the value for me as a test-driven development person is not there. The real value of test-driven development is that it allows me to design better solutions. And one of the ways of just kind of testing this theory of the use of AI at the moment is really think about the way in which we use it. AI is not very good at going back and correcting code that already exists. What it's going to do is going to regenerate the code from scratch. And if you think about the way that we work with code bases, it's nearly always about modifying what's already there. So it's not yet doing that kind of thing very well, it seems to me. So it's certainly useful at the point at which we are generating the new code, and it can help us, guide us, remind us how to use a particular API or a bit of tech that we're not that familiar with or something like that. Certainly useful. And it's remarkably good at some other things. So we've started using it in my business for doing silly things like identifying chapters in a video script. And it's brilliant at that. It saves us literally hours of time doing that kind of thing. But for other I'm not quite so sure about the writing of code yet. And I am pretty sure that that's going to come at some point. One of the other things that I think is kind of amusing, though, when you think about that, is that my bet is that when AI does take over the world of writing all of the code, my bet it'll be practicing something a bit like continuous delivery and the engineering principles, because that's what works.
I have this vision of the prime transformer, and his name's Dave. Hey, while we're at it, it would be remiss of me having you on not to mention this. The thing with yourself that I've always enjoyed. We met many years ago at Yao, and we've kept in touch. And you've always been willing and happy to give back to the community. And in saying that, one of the things that you've been doing recently is this repository of amazing videos of work. Talk a bit about that, because I think that a lot more people would benefit from hearing about that.
Sure. Thank you for saying so. So what happened to me was that I was working as a consultant, and I was traveling all over the world helping organizations to adopt the kind of practices that we're discussing. That was my life before COVID. And then COVID happened, and I couldn't travel, and I wasn't quite sure what to do. And I thought, I was speaking to my son, and I thought, I was thinking of putting some of my conference talks up on YouTube. And he said, well, he's a digital marketeer, so that was his profession. So he said, well, if you're going to do YouTube, why don't you do it properly? And so he convinced me to take this seriously. So since then, the start of the pandemic, almost the first week, we've been releasing a video a week, at least one video every week. So we've got over 300 videos now on all sorts of topics. So if you want to learn a little bit about test-driven development, continuous integration, these engineering principles that we're discussing about how to get a job, how to interview people to come into your organization, how to be a team leader, all sorts of random's not the right word, but a diverse range of topics associated with the practice of software development. There's something there for you, and it's opinionated. It's opinionated on purpose. I like the freedom to be able to say what I think, and sometimes I'm sure I'm wrong. And one of the things that's been absolutely delightful with this, though, is that we're just on the verge of hitting 200,000 subscribers on the channel. So it's one of the larger YouTube software channels, not the largest, but it's a decent audience, and we've kind of built up this community around it. So now there are people who I'm familiar with, I know through interacting with in comments and social media and all of that kind of stuff, and pretty much daily I get feedback saying, "Oh, Dave, I tried that idea that I saw in one of your videos and it worked," which is just remarkable. So it's been an absolute pleasure for me, and I mean, sure, we make some money from selling services around the edges of the YouTube channel and so on, but in large part it was about that giving back a little bit. Software development has been a remarkably wonderful career for me. I've delighted in it during the course of my time, and so I'm just trying to help people by offering what advice I can.
Yeah, and as I said before, extremely grateful. You've always been forthcoming and happy to help anyone that I know of. So, we touched base around some of that just recently, where there was somebody I put you in touch with. So, from my part, thank you for that, Dave. Look, we're really close to the end of our time. Speaking of that, how can people get in touch with you? What's the YouTube channel called? And I'll make sure that goes in the show notes.
Sure. So if you go to YouTube and search for Continuous Delivery, you'll find the channel. YouTube.com/continuous delivery will take you there. You can get me on X or Twitter at Dave Farley 77. And if you're interested if you look up Continuous Delivery online, you'll probably find me. So
Brilliant.
Those are routes to find me and my stuff.
And I'll make sure I put those in the show notes for everyone as well. Look, Dave, fantastic having you on at Talking Remote today. Don't forget, for listeners, remoteaf.co, click the community button, join our free community. Lots of people talking about lots of these types of things. Obviously, like and subscribe, please, for my YouTube channel. Keep me going. I want to catch up to Dave. Probably not going to get there. Anyway, that's all right. And of course, join our team, our newsletter, Team Craft. That'd be fantastic as well. Dave Farley, fantastic to have you on at Talking Remote. Thanks again.
My pleasure. Thank you.